Hello, everyone. Thank you for joining us today for the Merpay Tech Fest. In this session, I'll be talking about Merpay's work on quality assurance of machine learning systems. Let's get started. First, let me introduce myself. My name is Yoshizawa. I started my career as a financial engineer, and I started working in machine learning around 2014. I worked for a while, about 7 years, and then I joined Merpay in 2021. I'm mainly working on machine learning models currently, and especially around the credit limit. Okay, this is the agenda today. And first, I'd like to give a brief introduction of Merpay's services using machine learning. Next, I will talk about Merpay's concept of machine learning quality. And the third section, which is the main one, will be the talk about our efforts in the project with some specific examples. Yes, okay, let's start with the first one. I'd like to introduce Merpay's service using machine learning. So first one is the Merpay Smart Pay. This is a post-payment service that allows users to pay later for purchase made on Mercari or in physical stores. If you have used this service before, you may know that to how much can be paid later has been defined, which is called a credit limit. So the machine learning system is, being used for setting the credit limit. And then there is another service called Merpay Smart Money. This is a service that allows users to borrow money from Mercari. You can repay with the sales proceeds or points, or you can change your repayment plan on the app at any time. So it is very easy to repay. The services focus on the ease of repayment, and this service also makes credit decisions based on the usage records of Mercari, and machine learning is one of the important elements of this service. We are making credit judgment based on the user's behavior or activities, such as selling and buying via the Mercari app. And we determine credit limit by utilizing the activity data. Of course, we refer to credit information, but in Mercari, rather than so-called attribution information, such as the information of family structure, occupation, we use the information of the track record of the customer's behavior and activities. By doing so, the customers who are not eligible for the credit line can be entitled to get credit limit. So it was a brief introduction of the service. So then I'd like to talk about the quality of the machine learning services. When you think of the quality, since it is a machine learning system, of course, having high prediction accuracy is very important. But when you think about operating this as a service, we will need to have a quality to, other requirements than accuracy will be necessary. So for example, we will strive for quality in the form of a convenience and easy to use for our customers. And we also believe that the fair treatment of our customers is one of the qualities we strive for. And when we consider the requirements of the society, it is important to consider whether it will lead to a better society or not. Or, of course, compliance with the laws and regulation is also an important point of view. And if we look at the Mercari's group, of course, business continuity and profitability are also important, and of course, group synergies can be also considered. Since it's a machine learning system, it naturally requires trial and error, and machine learning is sensitive to changes in data. So it is important to consider how to maintain and improve quality based on these characteristics. So next, I'd like to talk about how to build the quality. I will address the 4 elements: data, model, system, and others. So I will discuss our efforts in these 4 elements to improve quality with some specific examples. So I will share with you some of the initiatives in project. The first is data. In terms of data, we are doing 3 elements or things for quality improvement. The first one is, in addition to the technical point of view, we are making sure to continuously process the data in such a way that it is legally and ethically acceptable. The second is to be able to respond flexibly to changing data, since data is changing all the time. The third is what I call verifiability, which is the ability to trace back the cause of the prediction result in the past. And from the next page, I will talk about specific efforts. The first one is to ensure the consistency of features, so that the features are processed in the same way during training and inference. And of course, in addition to using the same processing method, only data within the allowed range in the time frame should be used as input. So we looked at FEAST as a feature store and implemented it to realize this idea. And then next point is clean feature. Well, it is a matter of course, for those who work in machine learning, but those features are very important and contribute to the accuracy of the model. In addition, in order to fulfill our social responsibility and to fulfill our responsibility to our customers, as I mentioned earlier, we believe how to use a feature is important aspect. In addition to test and check whether there are bugs such as a data leak for each feature value. From a legal and ethical point of view, we are also checking with not only the ML engineers, but also with the business side to see if the features are appropriate to use in terms of privacy protection and fairness. So we make a judgment as to whether it is appropriate to use these features or not, and then incorporate them into the model. The third point, I mentioned it, the response to change. This is about how to check the so-called drift of the data as data changes. Well, we'll use TensorFlow data validation as a technique to check for data drift. And so we are checking for data drift, and we are using this for comparing data distribution between the training and inference, or between the current inference and the previous inference. But we are not fully automating this process. We have a team member who looks at the data and checks it. I mention it as an activity to look at the features. So our machine engineer looks and check the features. And if we find something of concern or problem, we discuss how to deal with it on the spot and respond it in a flexible manner. So the last part of this section on the data is verifiability. If there is a problem, in order to recreate the situation after the fact, we store the data. It's pretty obvious, but you are storing the behavior of the machine learning model, and on top of that, you are storing the learning data, the prediction data, and the hyperparameters and other parameters that are set for the learning inference of the model. These data can be accessed easily as well. That is that is important for verifiability. These are what we are doing about verifiability and example of our efforts about the data. I'd like to continue with the model perspective. So in terms of model's perspective, we divide it into two phases, development and operation. And we think about what we should do. During development phase, it is natural to check generalization performance and usability. But in addition, with the operation phase in mind, selection of an algorithm needs to be considered. I'd like to show you some specific examples regarding models. The first one is model monitoring. Monitoring of the model. After the model has been implemented and started to operate, we have implemented the system to monitor it on an ongoing basis. The purpose of this is to check whether the system is properly ensuring the generalization performance. We also detect abnormality when things like data drift occurs early and respond to it. And it may be true for other machine learning systems, but in addition to the raw output value of the model, there may be post-processing, and the final result may be delivered to the customer after several rounds of post-processing. So we monitor the system indicators over time, and when the accuracy deteriorates, we try to track which part of the system is the source of deterioration. Next is efficiency and automation of lead training. When selecting algorithm for machine learning models, it is natural to say that they should satisfy business needs. But I think that many companies are also considering selecting algorithms that are easy to operate. We need to consider whether it has accuracy to satisfy business needs. And there is also the question of how much accountability is needed and how much time can be spent on the inference, and also the lifetime of the model. How long does it take to retrain the model, and how often should it be retrained? These have to be considered as well when you select algorithm. So when we create a new model, we consider this point and select an algorithm that can satisfy each of these perspectives.
In our case, since we're using Merpay's behavior data, we want to use a model that is resistant to certain outliers and has a certain degree of robustness to external environmental changes. So we select our algorithm based on these perspectives. As the last line says, we are also studying and building an automatic relearning infrastructure and are testing automatic relearning and deployment. This is under POC now. The next is about edge case analysis. I think unexpected behavior of models can occur to some extent in any machine learning model. We can deal with what has happened by preventing its recurrence by improving feature values and adding rule-based logic, and we have done so in many cases so far. On the other hand, we cannot rule out the possibility of edge cases or bugs that could potentially have a significant business impact. Therefore, we are now considering the possibility of testing and preparing for such cases before or after they occur. Although this testing is still under development, we are considering the development of more controllable and predictive machine learning models. Next, I've talked about machine learning data and models. Now, I would like to talk about quality assurance for the system as a whole, not just the machine learning component. When we look at the machine learning system as a whole, there are two major rules in terms of quality. The first is the idea that the system as a whole compensates for weakness in the ML model. I think that the role of the ML system is to ensure that accidents do not occur when misclassification occurs, to supplement the machine learning component, and to ultimately ensure consistency with legal regulations and rules. The other role is to ensure the speed of system development, speed and accuracy of system operation as a whole system. When it comes to machine learning development, there is inevitably a certain amount of trial and error, or things often go differently than expected. In such cases, quick implementation of PDCA cycle improvement will be very important. So we are also focusing on speed and accuracy. The first is the complement to the machine learning model, which I mentioned earlier. In machine learning models, the risk of misclassification increases when the amount of information in the feature value is small. In such cases, we would develop a mechanism to generate predictions in a more robust way. Or when predicted values that deviate from service rules or legal restrictions are output, the system detects and processes them to appropriate values outside of the machine learning model. Next is the productivity and accuracy of development. There may be cases when you want to experiment and deploy them quickly when you need to retrain or have changed algorithm or features. We are focusing our efforts on how to streamline the experimental work with a certain amount of trial and error. There are a lot of things that cannot be completely automated. One of our efforts is the use of Vertex AI pipelines services to visualize the pipelines and improve the efficiency of experiments. The next point is automation, which incorporates human labor to ensure accuracy and speed in operations. GCP Composer is used to automate the machine learning pipelines like training, evaluation, inference, and post-processing of models. As I mentioned in the case study from the data perspective, machine learning engineers are also involved in checking the distribution of data, so we cannot say it is fully automated. However, it is important not to make mistakes in the confirmation processes or take too much time, so we are trying to automate the process as much as possible and to achieve accurate and speedy operations by minimizing the labor in an almost fully automated environment. In particular, we are looking for areas that can be automated by breaking down and analyzing operations in great detail, such as automating the data preparation process required for confirmation, notifying members of the confirmation process, and starting the process afterwards. We have also posted a blog on this topic for those interested. The above is about a machine learning system. However, from perspectives other than the system, there are some examples and practices that are useful in maintaining and improving quality. So let me talk about these in the end. I would like to cover mainly 2 points. One is the product's point of view, which is the environment surrounding the product other than the system. The other is continuity of quality. Assuming that the current machine learning system can ensure a certain level of quality, how can it be continued? The first point, product's point of view, means all members in a credit business, including the business division as well as ML team or machine learning team members, check each indicator and measure from a variety of perspectives. When there is only machine learning team, I think it is easy to focus on machine learning metrics only. However, by thinking about the business as a whole, we can discuss such things as what the result will be from a UX perspective and from a profitability perspective, and then check the final output. As we talked in the data section, as for the debate on whether or not to actually use these features, we use so-called privacy office to check whether they are good or bad from the point of providing fair services. After the ML engineering team makes the first decision on whether or not to use the feature, the privacy office will also discuss whether or not it is appropriate to use it in the effort of securing fairness. This slide is the last slide I will explain. Culture as the second point. This is intended to describe continuity of quality. I believe that culture is very important. we try to create a team culture that continuously improve quality rather than saying successful completion of the current project is everything. In other words, I think it is very important to have a team environment where members can easily make suggestions for improvement. The first is to conduct thorough documentation, which may seem conventional. I think the significance of documentation is to trace the basis of past decisions and link them to future measures and improvements. For example, when a new member joins the team, I think it is important for the member to be able to track back to why such decisions were made at the time of implementation from the point of quality continuity. Second is a credit report, and this is also one of the documentation. By describing what kind of credit was being provided at a certain point in time in a chronological table, in addition to the history of changes in the ML model, entire business can share the knowledge of environment where the data was generated at that timing. Final point is about the culture of trust and openness. It is also listed in the Merpay culture doc here. I strongly feel this culture has taken root here. I believe this fosters an environment where we feel it easy to speak up when we feel something is not quite right and make suggestions for improvement within the team or the business, which helps to continuously improve quality. I have been speaking for about 30 minutes, and this is the last one. Summary and a message. The machine learning team believes that the quality of the machine learning system has a direct impact on the customer experience and society. And I think it is an area that gives me a feeling of challenge and tension. We are required to have a great variety of qualities, not just accuracy, but in many ways. This cannot be achieved by teams' organizational skills alone, nor by technical skills alone. We are working to improve quality by mobilizing both organizational and technical strengths while growing ourselves. As the slide says, all for one team is the backbone of quality. The entire business and engineering sides are working to improve the quality of the credit business. I believe that fostering the culture I mentioned at the end is also one of the basic qualities that form the quality of our machine learning model, and by extension, the quality of our credit product services. This concludes my presentation. Thank you for your attention.
Hello, everyone. So this is, I'd like to have a QA time for the quality assurance for the machine learning system that Merpay works on. So I'm a facilitator of this session, Gokujima. I'm called Goki in my company. So I'm also working in the credit modeling team, and I'm a tech lead of the engineering side. I'm working with the same team as a presenter. And so I do like to answer to the questions from you. We are still accepting the questions, so please post the question either the YouTube Lives or the Twitters. Hashtag of the Twitter is Merpay Tech Fest. Hashtag Merpay Tech Fest. So first, Yoshizawa-san, thank you very much for your presentation. Let's get to the question. We received some questions from audiences. So, needs of the market and needs of the customers have to be reflected upon the features value. But how do you combine them with the variables, combine the variables, and how much accuracy did you improve? Thank you very much for the question. So this is a very question touched the essence of the machine learning, and since it's essence, so much essence, I cannot directly answer to this question. So I am thinking what else I can tell you. First, the differentiation of us from the other credit business operators. So we have the Mercari's behavior data. On the Mercari's platform, people are paying or buying and selling. They're doing the transaction. So that data can be a base to define the feature values. So if you use Mercari platform, you may have an idea which kind of data is being used. So there are different feature value engineering method, but we also use them to define. The improvement of the accuracy is not easy thing to do. Maybe I'm sorry I cannot answer to this question, but thank you very much for the question.
Thank you. So let me ask you a question. So it is related to this question. So in selection features, you mentioned that you also consider fairness. So could you be more specific? So what do you do to be fair in the selection of fairness features? What to keep fairness? So as for fairness, this topic is often dealt in the machine learning field as well these days. So we also pay attention to this concept. However, one of the best strategy is not to use sensitive attribute in the feature. So fairness, runner, awareness. And in addition to this, what we are focused on is, for example, there can be some proxy variables that can, there can be some variables that can be proxy variables of the sensitive attribute, and we try to avoid the usage of such features. Let me explain what it means. So they are not sensitive attributes themselves, but in general, these variables can refer to sensitive attributes. Well, in the end, it ends up referring to sensitive attributes, and we try to avoid such features. So whenever we think of introducing new features, first our ML engineering team decides primary decisions whether we should use it or not, and also furthermore, privacy office will make a judgment and evaluate whether this would be all right to use it or not, and the final decision of the usage will be made as a company. That's how it goes.
So it's not only engineers, but then, this is a consideration by the entire company, right? So relating to this question, regarding fairness, have you done any researches, or are you involved in any researches regarding fairness? I'm personally interested in this field, so I am doing some researches that within the machine learning team. Periodically, we conduct the study session, and in those sessions, we talked about quality and fairness. So we share the knowledge among the team members. actually, this study session talked not only the fairness, but we shared the contents of the books and articles that we read, like a fairness of machine learning or the graph theory as well, which was discussed in the earlier session. Those are the topics that we shared. And also, Vertex AI, which was introduced in this session, was shared by the team members because some team members tried it. And so he shared that experience. So in this study session, we share the knowledge among the team members. So not only the fairness, but also the different topics can be shared in the study session because I have participated in that again. Thank you. As a Mercari and a Merpay, this is the area where we pay a lot of attention at Mercari and Merpay. Thank you.
Okay, let me ask you a different question. So this is just an example. So if we do not have enough feature data and you have a risk of misclassification, so if you would like to apply machine learning in such case, you mentioned that you would choose more robust methodology. So what are the robust methodologies? Could you be more specific about that? Well, for example, so this should have a rule-based logic, or you should have some multiple machine learning models, and you make distinction depending on the cases. That's what we are doing right now. I think this might be one of the answers. So if we do not have feature values, in this case, then based on a certain condition, we apply rule-based logic to make a decision. And in some of the cases, there are some machine learning models that can be applied. So we make a distinction in the usage so that we can have a nice result from an overall perspective. I think that will be my answer. Thank you. So you do not specific to a single model, but you try to use multiple models as well as try to utilize rule-based models so that we can have a comprehensive value. Okay, thank you very much.
We still have some more time. So last question then. Towards the end of your presentation, you said that you feel tension or the nervous. So can you give some examples? Well, this, I'm nervous in this session as well. But machine learning model is implemented in a society in different cases. The model that we developed is something that can be used by the actual customers. And therefore, I'm very nervous, like retraining of the models is one thing that I run a lot of checking, and also data analysis and code review. And, in those engineering tasks, I always feel nervous and to do the things right. And it's true with the entire company, but each person has talent, and each one leverages the talent, and we and we can work on the trial of the designing and so on, and so we can also get involved with the business side. And but of course, it's also easy to get a support from our team members. So the questions and questions can be shared, among the team members, and so we have a very good sense of nervousness and positive sense of nervousness in the team. Yeah, positive sense of nervousness. Maybe in our team we have a psychological safety secured in our team, so it's very easy to work. And so it's about a time, so we do like to close the Q&A session. And we have a survey for the audience, so please feel free to give us feedback. Thank you very much for your attention. Thank you.